So today we will discuss the one of the very important interview question, which is merge to sorted array. So we will have two array 1 and array 2. You can see what we need to do is we just need to calculate the array. We just need to get one array which will be sorted array, and it will have all the elements of the array 1 and array 2. In simple words, we just need to merge both the array and the output array should be sorted. For example, we will have 10, 50, 70, 30, 40, 89. So the merged array is 10, 30, 40, 50, 70, 89, which is also sorted. So this is the question. All right. So I would say just think about the question. What you will do, pause the video and think for a moment. So the first approach which is coming to my mind is I will just merge both the array. So merge both the array in normal way, just like we will run the loop for both the array, and once the array 1 is complete, so first copy the array 1 and then copy the second array. Now sort the array. All right, now sort the array. So first of all we will just copy the first array, then we will copy the second array, then we will sort the array. So this approach is fine, but the problem with this approach is it will take time. Complexity of this approach will be because we are doing the sorting. Okay, sorting. So for sorting, we know if we'll use the best sorting algorithm, then sorting will be n log n, right? Now here n is nothing but the size of both the array. Let's say size of first array is m, size of second array is n, then the time complexity for this particular approach will be m plus n times log of m plus n. Okay, so which is kind of costly. Can we optimize it? Think about it. Can we optimize it? So let me create new slide. Method 2. Yes, we can optimize it. Yes, we can optimize it. What approach we know? So here we are not using one property that both the array are sorted already. So we need to think about, hey, can we use the sorting logic of both the array and we can merge them? So there is one concept which is very similar to the two pointers. So let me show you through an example. Let's say we have this array. Array 1 is 10, 50, 70. So here I is pointing to the first element, which is 10. Second array is 30, 40, 89. J is pointing to the first element of the array 2. So we'll take two index and both will start from the first element of both the array. So I is 0 and j is 0. Now what I will do, I will just compare both the element at the index I and j, and whichever is smaller than, we will pick and we'll store into our answer array. So for example, here we know that array of so here I can say that array 1 of I is smaller than the array 2 of j. So just copy the smaller one in the answer array, which is 10, and just increment the I. So you need to increment the index for the smaller element. So I is smaller, increment the I. Now you will see this next diagram is nothing but I will now point to the 50 and j will still be at 30. Again compare both 30 and 50. So this time jth index element is smaller. So just copy the 30 here and just increment the j this time. So now j will be 1. You can see j will point to 40 and I will point to 50. Again compare both the elements, so we can see that 40 is the smaller one. We'll increment the j. Now j will go to the 89. Compare 89 with 50. I'll copy 50. I will be now 7. I will point to 70 now. 70 and 80. So 70 I will be out of index. So just copy the remaining element of the array 2, which is nothing but 89. So we got the array. Now in this particular approach, the time complexity will be length of summation of length of both the array. So here what I'm saying is the time complexity of this approach is nothing but O of m, which is length of the first array plus length of the second array. Because we are not doing sorting again, we are storing the data in such a way that the resultant array will also be sorted. So don't you think this is a very good approach? Let's quickly jump to the code and we will try to understand it, how actual code is working. So let me create one class for these. Okay, so I'll say merge to sorted array. Okay, now I will define two array as the input. So first will be, let's say, array 1, which is nothing but the, I'll take the random 10, 30, 50, I don't know. Second will be, let's say, array 2. I'll take the different length this time. So let's say 20, 25, 40, 60. Okay, so here m is the length of first, which is nothing but array 1 dot length, and n is the length of second, which is nothing to array 2 dot length. All right, I'll take one answer array, which will be which will have total number of elements as m plus n. I'll take two variables, one is the I, another one is j. So what you need to do, so here the loop will be I should be less than n, m, and j should be less than n, which is the last element. Now you just need to compare with the smaller element. So let's say if array 1 of I is less than array 2 of j, then I need to store the smaller element in the answer. Now at what index I need to store? So let's take the k, which is nothing but the 0, starting index of the answer. So you can just do the k, it will be nothing but the array 1 of I. Increment the I and increment the k, because next index we want to store at the k. So if this is not the case, okay, what we need to do, we need to store the k, the second array, which is nothing but the array 2 of j. Increment the j and increment the k. All right, so once we are out of this loop, there are two possibilities. Either we have reached to the end of the first, or we have reached to the end of second, or we have reached to the end of both. So we are not sure because of which I or j we came out of the while loop. So we just need to run one more loop here just to make sure we are not missing any element. So it will be this way, just increment the I and increment the k. Now what this loop means, if array 1 elements are left, okay, then this loop will work. If let's say array 2 elements are left, then we just need to run the loop for j less than n and just like above, we just need to store the second array this time. Increment the j, increment the I. I hope it is clear now. So our answer array will be now answer is sorted array, sorted, and it has all the elements of both the array. All right, let's print it out and we can verify it. And let's say index, which is nothing but 0, and index is less than the m plus n, because this is the length, total length for the answer array. Just print out. So system dot out dot print, I will just print answer of index. Let's give this space in between just to. All right, what we have done, we have defined two array. Length of first is m, length of second is n. New array will be of length of m plus n. We'll run the loop until we reach to the end of any one of them. If anyone has few elements left, we'll use these two logic. We are just printing it. Okay, let's try it. So we should get the answer as 10, 20, 25, 30, yeah, which is perfectly correct. You can see 10, 20, 25, 30, 40, 50, 60. Understood? So now after every question you need to think about the time. How much time it will take? We have seen it will take the length of both the array. So m plus n. Space complexity is nothing but the O of m plus n, because we are taking one answer array of size m plus n. All right.